Okay, for problem number 6 of worksheet 3, we're trying to figure out the internal forces on the boom and the tensions in the rope. Okay, so let's go ahead and draw a free body diagram here for the boom. And there would be a force here of tension. There would be a force here of tension. There would be a possible upward force here at the hinge and a force horizontal at the hinge here. And let's label these. This would be the force of tension from A. This would be the force of tension from D. This would be the support force on C in the Y direction. This would be the support force on C in the X direction. And I do kind of know what this force is because it must be the same as the weight of the load. So I've got that one. But the other three are unknown. So I need to resort to torque to figure this out. I'm going to pick a pivot point down here to eliminate two of my unknowns. And so my torque equation becomes the torque from D equals the torque from A, which would be the force from TD times the length, which I don't know, times the sine of, do some geometry, find out the angle is 13 degrees, equals the force 2,000 newtons times the length L times the sine of 42 degrees. The L's cancel, solve for the force of tension from D, and that's going to be equal to 5,949 newtons. Okay, then I can figure out these two components by setting up some net force equations. So NCY will be plus, will be equal to FTDY plus FTA. So NCY will be equal to 5949 newtons times the sine of 35 degrees plus 2,000 newtons. And so NCY is equal to 5412 newtons. I could figure out the NCX as well in a similar way. Set up a net force equation. NCX must be equal to FTDX. So NCX is equal to 5949 newtons times the cosine of 35 degrees. So NCX must be equal to 4873 newtons.